This old thing is a bed slinger. They're known for a few reasons. Firstly, they're quite cheap and inexpensive to produce. Second, they sling the bed backwards, forwards. This makes the quality of the prints questionable. It's quite difficult to tune these, and of course, they're not very fast. In today's video, we're looking at the LH Stinger, a bed slinger with no compromises. The LH Stinger is an open source project developed by Lima Hayes. There's no room for magnetic build surfaces, fancy probes, or even lead screws. This thing is all about the raw performance, and it boasts speeds of up to 1000 millimeters per second and accelerations reaching up to 100,000 millimeters per second squared. It's mesmerizing to watch this thing at work. So let's take our first steps and dive right into our own Stinger journey. So this is the first two layers you'll get within the Fysetc box. I haven't really been through this yet, so I'm excited to dive in. I believe this is a PEI sheet for the build surface, which, let's get started there. So that is quite obviously the heated bed, made of carbon fibre. I do believe the PEI sheet just sticks straight over the top of that once everything's assembled. There's no magnetic build surfaces here. Obviously this is built for lightweight, and that is an incredibly light piece of carbon fibre. Nice heater built in there. Then we have the bed frames, also carbon fibre. They appear to be laser cut. I do believe these have to be glued together, but we'll look more into that when we get to building the printer. So very good. Now that appears to have the thermistor built in to the bed, heater, and a nice XT60 there on the end of that, so make connecting that nice and easy. The printer is fairly modular, so you get a like a daughter board and a completely separate electronics box. Well, let's get started. We have end stop switches. Seems to be 4 of those in there, all pre-wired, pre-terminated. Brilliant. Some carbon fibre parts. I can't tell you exactly what everything is yet because I've never built one of these. I'm not sure anybody has. This could well be the very first look at the Fysetc kit. We have more pre-terminated wires. I do know that's a Raspberry Pi connection for the control board. A USB-A to USB-C connector. That appears to be the heater. This appears to be the hot end heater and thermistor. It's a cartridge style thermistor with a nice braided cable, and the heater cartridge is a 70 watt heater cartridge. That's quite substantial. And we have some Bowden tubes under there. There's a boring, we're not going to open them. Power cable, 3-pin UK for me. That side. These are pre-terminated stepper motor cables and 3 EMC 2209 stepper drivers, along with what looks like some thermal grease and an SD card. So, jumping into the power supplies. First one here is this is a 48 volt power supply by Monson. Actually, not a big deal in the UK, but I believe you'll have issues in the States with that. after a few months' time. It's a very small power supply for a 48 volt system. And then we have our standard LRS 350/24 meanwhile power supply. This is the 24 volt. Electronics voltage is already set to 230. Now that one is slightly different to the one you get in the forum kits. This one has a fan built into it. It's interesting. And finally, breakbeat board from LH Engineering. Now this one sits at the back of the printer, and it just has a wiring harness that connects it to the electronics box, or e-box as it's called. And it appears to have hot end connectors, hot end CAN. Well, I'm unsure about that. We haven't seen any CAN bus. And all your motors and whatnot connect directly to this, which is essentially just a breakout board that gives you a nice micro-fit connection. I'll be interested to see how this works. I believe the purpose of this is so that you can use an enclosure and just run one bundle of wires directly to this. So we'll see how that's used. And that's it for that top layer. So moving that one aside, get to this one. Most importantly here, I believe, would be the spider. So this is a high voltage version of the Spider V3 that uses a slightly different chipset. This one is the H723 STM32 processor. It's generally the same as the old Spider V3, however it has a few more high voltage stepper driver ports, as well as a few minor reconfigurations. So it has a USB-A port here now, the boot and reset buttons have been moved, and there's an extra fuse that I can recognise, along with obviously power input for 24 and 48 volt. So that'll be a nice addition. We'll look more into the wider board during the build. And this build does use preloaded rails. So they're MGN12 rail. They're all very heavy duty and Z1 preloaded. So we have 1, 2, 3 of those, and then 2 shorter ones, which I believe are for the Y-axis. This one's open. So Fysetc branded, not the hollow rails, but they do have good preload. They don't just fall around like you'd expect. Now onto the belts. They do have branding. This is a GT2 6mm belt. I haven't seen any branding so far. And those are Gates Power Grip GT2 belts, the 6mm version. That's nice to see. Now, I'm not going to unravel that to see how much is there, so we'll just assume enough. Now, one thing I quite like about Fysetc actually is they provide these carriage blocks for removing your MGN12 carriages. These ones are actually quite nice. They've got a little stopper on the end to stop you accidentally knocking it straight off. And they're useful when re-greasing or cleaning your rails. And I don't have any MGN12 ones, so nice to have. Over here we have these appear to be some kind of isolating pad. They're really hard rubber. It doesn't say anything about what they are, but I looked through the manual and I'm sure we'll find out. and this appears to be the electronics power connections that connect into that breakout board that we saw earlier. Very nice, quick and easy connection there, and those are marked as hot end, ground and heated bed. So these must come directly from the spider board to here, and obviously a ground. And these are another pre-built wiring harness, Q-stop, thermistor, Y-stop, PWM, unsure what that's for, and extruder. So these also break out from the spider board into a small plug, plugs into the sensors plug on the breakout board. Nice tight fit. Very tight fit. These little wiring harnesses are quite nice. The pre-applied wire wrap. There is a wrap kind of around the wire instead of a braided covering. I do have some braiding, so I may change that. And onto the fans. What do we have? So these appear to be standard 5015 blower fans, 24 volt, Chizo brand. It's the same brand as Fysetc offers in all of their kits, and we've had no problems with them to date. And these are also 24 volt fans. I believe these are for the electronics box, and these are 60/30, I believe. And then these behemoth blower fans. These are the auxiliary part cooling fans. So we should have no issues cooling the printed parts. And I imagine those are very loud when they're running, but we will see. Yeah, small, I assume, hot end fan, maybe. Another belt. Now those are belt loops. There's 9mm belt in there and 2 gates belt loops. Another wiring harness, one for the motors. Again, I'm really happy with the quality of these actually. They're well terminated. I like the sleeves, very nice. And again, these are keyed differently, by the way. The stepper motor one has 2 extra pins, so you can't make the mistake of getting them in the wrong place. However, with a little force, you could install the sensor one into the steppers. However, it would take some force, and you'd have to really know that you're trying to do that. As you can see, it plugs in nicely to the sensors one, and stepper one to the steppers. And a nice tight fit, definitely not going to fall out. And here we have some more bits of hardware. We have some 5mm pins. Again, I can't say what they're for. One of them appears to be a D shaft. The rest are completely round. Oh no, 2 D shafts in there and then 5 round smaller ones. Some springs. Again, I have no clue what you'd use springs for. I'm sure we'll find out. 6x3 magnets, and I assume reverse Bowden ECAS connectors there. Now moving on to this final bag of what appears to be pulleys and idlers, and more pulleys, more idlers, flat bearings. There's appeared 625 RS bearings in there, and finally two larger pulleys, 2 GT 82 pulleys there, which are very nice actually. Anodized silver as well, not just machine silver. They're a bit different and higher quality than the ones we get in the Voron kit. So, let me get this packaged up and we'll move on to the next layer in the box. So, let's start off on here. We'll start at the back with what appear to be the extrusions. There's a piece of 2020 extrusion there. Appears to be T-slot. And beneath that is a huge piece of 3030. Again, T-slot. That must be 3060. And there's two of those the same. And 3090. There's two of those in there. And you can really get a feel for just how rigid this printer is going to be. Nozzle input shaper. Yeah, I've seen these. So it comes with a USB cable. And I believe these simply fit directly onto your nozzle to get the most accurate input shaper results. I've never used one, but we'll give it a try. I haven't seen a tool head board here, so obviously we won't be using any kind of inbuilt input shaper. And where to next? 3-pin power connector, unfiltered, same as you get in the Voron V0s. A full roll of Kapton tape. I'm sure there'll be a need for that. Some wire wrapping, that's completely clear, empty rather. And some, these are just the profile connectors for connecting the various profiles together. They appear to be cast. Fairly decent quality those, and nice and rigid. We'll then empty the whole bag. There's quite a few there. Moving on, these two plates. Again, making the assumption all of these are just connector plates for the extrusions. And what's interesting is these are aluminium and they are machined and then anodized, as opposed to just being cut from steel plate, which is interesting, an interesting choice. However, I imagine that those are as per the bill of material. Moving on to these little jewellery boxes here. QHV 5160. These are not an engagement ring. These are 5160 Stafford drivers, the high voltage system, named 5160 because they can go up to 60 volts. I've never actually used these, but they look quite nice, and very beefy heatsink to go on top of those. Be interesting to see how those perform. And we get 3 of those up here. Now, one of the things I found interesting about this kit that you generally don't get with Fysetc products is the branded hot end. So we have what appears to be a genuine Fysetc Dragon ultra high flow hot end here. So that's all brand new and sealed. Let's open that up and have a look. And there we go, a brand new Dragon hot end. Appears to be all legitimate. The ultra high flow attachment already in there, and that would be the standard flow sock should you need it. Never actually used a Dragon before. I do have a Rapido on my 2.4, and I assume these are 0.4 and 0.6mm nozzles that come with this, and it is. So that'll be a nice addition. And then we have our obligatory set of snips. I think that would be my 12th pair. Are those it? Those look slightly bigger than my normal ones. Nope. Just the normal snips. Always handy. Never sad to have another pair. Huge. In fact, well, I think this bag of hardware makes up the majority of the weight in this printer, or in this kit rather. And as always, as you'd expect from Fysetc, all of the bags individually labelled. If there's anything special, there is of course a lot more M5 hardware on this than you'd usually get in a Fysetc kit. It all looks decent to say the least. M3 threaded inserts. Interestingly, the monitor's short, but they're 7mm long. Oops. T-nuts. Because there are no roll nuts in this kit. It appears that they're all T-nut. Lots of M3x12. And even some M8 bolts. Really. And a small bag of L3 drop nuts with the 3030 profile. So again, nice to see everything labelled well. It makes assembly that much easier. Unless I lose them. Here we've got a small bag with some M3 hardware, Bowden tube and another Allen key, which I believe will be for this, the CNC Sherpa Mini, as they call it. Never used a Sherpa before. Most of my printers use Galileo or Orbiter extruders. However, I'm interested to give this one a try. See a lot of people use them without issue. And it's all CNC machined. Just feel very nice and satisfying, actually. And it appears to be using their helical gears, the CNC PON gears, that is. And interestingly, not a normal Fysetc motor on the back of there. This is labelled as a Moons motor. Oh, very interesting. We'll see how that goes. It'll be my first time using one of those. And then we have a standard Numa 17. It feels like it's been a long time since I've seen one of these after working on so many V0s. This doesn't appear to be anything special. It's a 42HS 3418 22B19, and there's the detail on it. And there are two of those, and then there are three of these slightly bigger 42 HSC 6406C 24B20. These will be the high power motors. Bit of fluff in there, it's not going to go well. And there's the details on those. The schematics for the motors are available on their GitHub. At the time of filming this, that's all that's available on their GitHub for the Stinger. And that concludes the unboxing. I hope you'll join me for the assembly videos. I'm unsure at the moment whether these are going to be live streams or just an assembly video. However, I'm very excited to get going on this. As a disclaimer, this kit was provided free of charge by Fysetc for research and review purposes. However, they have no input in the outcome of this or any videos on the channel, and will not see this video before you. Thank you for watching, and if you don't want to miss the next leg of our Stinger journey, don't forget to subscribe and turn on notifications, and I welcome your comments and feedback on the videos and projects. If you want to get your own LH Stinger kit, you can find them at the links in the video description, as well as several useful resources such as the LH Stinger GitHub and Git Discord server. I want to thank Lima Hayes, the creator of the LH Stinger, for his cooperation and guidance, and our official filament sponsor, Filamentive, who have provided us with a huge batch of filament for this and many of our next projects.